Good afternoon, everyone. Thank you. Thank you, Smithers. Thank you, everybody, for making this event so engaging. I think I just need to mute myself. Yeah, okay. Okay, so we are APChemi or Agile Process Chemicals, APChemi Circular BV, headquartered in Netherlands, operating out of Mumbai. The topic of my presentation is commercial scale tire recycling, how 10 to 30% of rCB integration can happen with 45 to 55% carbon footprint reduction as such. Uh, a quick brief about company as such, and then I would dive into the specific topic. We are leaders in pyrolysis in terms of setting up the number of plants. We turn non-recyclable plastic, tire, as well as biomass into value. The video that you see in the background are the visuals from the actual projects that we have set up at industry scale. We've developed 47 pyrolysis plants since 2007. We have set up 3 pyrolysis oil purification plants, and we own our own uh, 15 to 30,000 liter per day fractional distillation plant for tire pyrolysis oil near Mumbai. We've transformed 179 million kilograms of tire plastic over 1.3 million hours of technology performance. We're supported by Shell Petrochemicals. We're working on up to 240 tons per day pyrolysis projects in Europe and UK. We've created over 3,000 jobs since 2007. Recently, we've created more than 7 proof of concepts on chemical recycling technologies, including 3. Right now, this number has gone to 4. 4 of the plants to which we'd given the pyrolysis and oil purification technologies are ISCC Plus certified, supplying the oil produced out of these projects to refineries for production of circular plastics and sustainable chemicals, circular polymers, as such. We have 12 patents in pyrolysis and pyrolysis oil purification. As far as the pyrolysis reactor technology is considered, we've worked on all these 3 kind of technologies, plus there's one more slide on this. So for a small processes, maybe up to 1,000 kg or something, you can also have a vertical reactor. Up to 5 ton, some people have gone on vertical reactor. Then there is rotary kiln. We've done rotary kilns as well for plastic and tire. Our specialization is the seal of the rotary kiln. We've successfully sealed the rotary kiln that also has a diameter of 2 meter, rotating at RPM of 4. So we can bring in the rotary kiln seal part of it as well. Uh, this is our typical plastic or tire, both pyrolysis reactor. In the same process, you can switch over the feedstock. It has agitator inside and then carbon discharge from the other side. So you don't have to open the reactor for feeding the new batch as such. And then what we've also done is connected these reactors, multiple reactors together to convert the batch process into a pseudo continuous process, wherein even though individual reactors are working in a batch process, the overall process works in a continuous manner. We have our own pyrolysis oil distillation plant near Mumbai, where we are able to distill around 15,000 liters to 30,000 liters of tire pyrolysis oil into light, middle, and heavy fraction. Our samples have been approved for production of oil-derived carbon. We can adjust the flash point as well. So if we go into the details of fractional distillation of tire pyrolysis oil, you will get these colors. And depending on what fraction do you separate, at what temperature, you will find different colors. So from light to very heavy, you will keep getting these different colors as such. Um, Now, coming to the second part of the presentation, Uh, as far as the industry reality is considered, right now we are moving from high risk to engineered product. A lot of initiatives that industry wants to take on rCB More than 80% of projects have failed on the quality consistency. 60% of producers lack feedstock control. It's not very clear whether I'll be able to source only the truck tires or some car tires will be mixed with it, or off-road tires will be mixed with the feedstock. And what we are looking at is, rather than going for, say, 0.5% ash content, how can we reduce the ash content to 8 to 12%, and have a fit for purpose kind of an rCB grade, rather than coming up with a very low ash content rCB grade as such. So for years, the industry had chased unattainable less than 1% ash purity, leading to very high cost and project failures. The reality is that rCB is a new material and there is no direct replacement as such. Thank you so much. Uh, and market gap is that success is not about owning pyrolysis reactor, but it is about creating a fit for purpose engineered product with a validated pathway from feedstock to the final specification as such. Now, in case of de-risking of the feedstock, of course, what is ideal for tire selection strategy by ash content is that we would like to have, say, around 12% of ash content. However, we see that Asian PCR around, say, 16% of ash content. European PCR, it can go even up to 25%. So what we can do is we can offer a feedstock validation service, in-depth characterization of the feedstock, and optimize the blending strategy to arrive at the most commercially viable option. Um, Smart purification is important for achieving optimal return on investment. Very high ash rCB can be processed to reduce the ash content as well as recover the zinc as the byproduct. And zinc removal kind of creates the necessary revenue stream that enables certain reduction in the ash content in a commercially viable or friendly manner, wherein whatever cost that you put in for environmental compliance can be also compensated by the amount of zinc that you recover. And then you have kind of an optimized rCB, not targeting 0.5% or 1% ash, but rather targeting anywhere between, say, the slide said 8 to 12%, but I would say anywhere between 8% to 15% based on what are the requirements of the off-taker. So why chase 99%, 9%, 9% purity? I fully agree with you. In case we can have lower purity, but it just works for the customer as such. And this kind of slashes the processing cost by 40 to 60% while still recovering certain quantity of valuable zinc to make the entire process viable. Um, for fit for purpose grade, what we've done is we have done some validation. We've seen that raw rCB can have ash content around 18-90%. You can have an optimized grade which can be around 10 to 12%, and then there can be a premium grade which is like around 4 to 8% as such. So our product tires, we are looking at, say, less than 7% as premium grade. Standard can be around 8 to 12%, which can have much wider application in the market as such. The thermal treatment process also, what you can look at is, if you try to do a thermal treatment at 900 degrees Celsius, then you're just getting 0.3% extra advantage compared to doing a thermal treatment at 600 degrees Celsius for a little longer period of time. So comparing how extensive is the thermal treatment and what is the value that can come out of that thermal treatment, some pilots can be done on that as well. So as far as our commercially validated track record is considered, our ISCC plus certified facilities are there to people who we've given technologies. We have our own tire pyrolysis oil distillation plant, and we are able to upgrade the feedstock value as such. Uh, what we would suggest is that three-phase approach can be taken by the entire industry. First, target for maybe 5 to 10% of integration of rCB with rest of the carbon stream. Then, in the proven commercial rate, maybe around 15 to 20%. And then at advanced stage, try to target 25 to 30% rather than targeting 100% replacement of virgin carbon as such. So we can start with lab validation, pilot, sample production, supplying those samples, and then uh, taking up the pilot technology and then scaling it up to the industry scale as such. Uh, Virgin rCB, now this has to do with life cycle and analysis, how much of carbon energy consumption is there. So in case of virgin carbon, the energy consumption is somewhere around 15 kilowatt per kg of the virgin carbon black that gets produced. Compared to that, rCB is somewhere around 9 kilowatt per kg, and we are able to reduce it further by around 20% because of additional waste heat recovery expertise that we have developed. Now, as far as carbon footprint of the rCB is considered, common market claim is that 80 to 90% reduction of carbon footprint is there compared to the virgin carbon. However, reality is that it is somewhere around 45 to 55% reduction. The difference is because unrealistic claims often ignore the crucial energy inputs from the post processing like milling, purification to achieve ultra low ash or something. Also, scope 3 transport emissions are excluded. Some of the life cycle analysis we've seen that they are considering renewable energy for electricity. So practically, probably we can say that around 45 to 55% reduction in carbon footprint is there rather than 80 to 90% when compared to the virgin. Um, this slide has been covered in the discussion, so I'll just skip it a little bit. I would like to close the presentation quickly now. So approach would probably first do some validation, do pilots, prepare fit for purpose samples in collaboration with us. And once the samples are approved, of course, we are happy to scale up the technology from pilot scale to a commercial scale, as we have done multiple times in past. As far as advanced TPO upgrading is considered, from tire pyrolysis oil, the light and middle fraction goes to the refineries for production of circular plastics or circular polymers and chemicals. And the heavy fraction, of course, has higher BMCI that goes for production of the oil-derived carbon. These are the three grades. We can say BMCI of 77 has flashpoint of around 130. 80 would have around 172, and then in case BMCI is around 84, then in our process we've seen flashpoint of 182 as well. So various grades of BMCI or flashpoint we can manufacture. Uh, Going in long run, maybe over the period of 3 to 5 years or 10 years, what we would recommend leaders would do is they would produce variety of qualities of end products. There can be premium rCB as one of the byproduct, which would be around say 7%, less than 7% ash. There can be standard rCB. There can be rCB as such without any purification. There can be also recovery if for example, if 10,000 tons per year of tire input is there, there can be a zinc of around 150,000 to $250,000 worth zinc can be recovered. Pyrolysis oil recovered stream. So if you have multiple end products that you can produce, that can be very interesting as such. So happy to collaborate starting from a pilot scale and then scale it up together. I'm here throughout the day. We bring in world-class engineering onto the table and figure out the journey for the entire industry together. Thank you.
Any questions for Suhas?
Thank you, Mr. Dixit. The classification what you made premium rCB and standard rCB and optimized rCB, it is this kind of nomenclature came from where? It is less than 7%, 8 to 12%. What is the basis of that?
Now, these are not any international standards or something.
This is standard.
No, this is where we see the market probably would go. This is our analysis of the situation. This is not any specific standard as such. This is our view of the situation.
Yeah, that's why you get customers' feedbacks and accordingly you have categorized 3 categories. Thank you.